Welcome back. My name is Norbert Hartl, and this is a two-part talk. I will do the first 20 minutes, and then Markus will take over for the second part. And this is actually the sequel of my last year's talk, so maybe one or two participated in that. The story about it is my multi-decade struggle with database management systems and how people do not criticize what databases are. And databases are always kind of magic. That was the last title, There's No Magic Until You Talk About Databases, because I heard it here, so if you say you store it in files, then everyone, well, no, you cannot do this. And so yes, but almost any database does this. So you can go over a network socket and then to disk, but it will end in a file system. So that brought me to the question, the second part of the last year's talk was that we had a big tech stack and we just started to evaluate what do you really need, yeah? And then in the end, there was only 20% of the components left over. And when I was looking at a database system saying, okay, let me ask some questions. So what do you really need to be a database or to be useful as a database? And that brought me to saying, what would be the definition of a database? Let's just take another angle. And to me, the beginning is that the definition of database is that it's the acceptance of failure in developing fast and cheap non-volatile memory. So what we take for granted is that we have main memory and disk, but there's no reason that it has to be like this. It's just like it is. So, and that we have main memory and persistent memory, we always need to copy back and forth and map and struggle and all the time. And usually it's not needed, but this is the case. But database systems should at least make this a bit easier for the user and not mapping everything to JSON, sending network socket, and so forth. I really remembered about a quote about a guy here. Not sure if you said it like this because you said it to me, but this was something I memorized. It's like, you don't want to send your data to a program, you want to send a little program to your data. And that was already, wow, that's exactly what I want. That's really, because usually you have database system and you make a query and you get a huge pile of data, and then you look into what do I need really? And it doesn't sound really good. But the same guy, a few years later, wrote that on a mailing list. Before you go off and invent a database, you might look at Gemstone and remote service replication. It's like, wow, that's exactly what I do not want. So that's okay. A database, for me, it's always strange, and I love talking to people because the imagination about databases it's not religious, but something else. So people always think a database is something like the rock. It's like the solid. You cannot destroy, and it's just like it is, and you put all your trust on it. This is Pharo. Huh? This is Pharo. Yeah, I know. Yeah. Huh? Pharo is a database, by the way. So, but that's the topic of the talk. What is a database? An image persistent is a really cool way of persisting data. It's just not suited to a lot of use cases. That's the whole story. So, but that is how people think a database should be. And this is how I think a database should be. So it should be fun. It should be inflatable. It should be movable to another direction, so to another party, and then start it all over again and try, fail, and repeat. Yeah. So it says that they were saying that from Pharo image persistency is a good thing. Yeah. And then there is, if we don't want to go to SQL, document storage, blah, blah, blah. On the other end, there's Gemstone, and then there's a huge valley. So thin air, everything. I mean, we have no way of filling that up. So that brought me back to make our product, saying performance and scalability is more an asset of architecture than of a single database system. And the story I told last year, I was using Omnibase, an ancient version of a Smalltalk database. After all, it turned out that it was not open source. And then I needed to start all over again and say, okay, screw it, I'm doing it again. So that's the birth of soil. So it was created actually last year's ESUG because I had the slide at the beginning, but no code. Just because I was the original author of the database was got notified because of my talk of the last year's ESUG, and then he contacted me and just said it's not open source and you should not change the name and everything. All right, so but in the last year we were working on it. So and it's a simple, so it's a lightweightness. It should also be simple. So it should be you load it. There's no dependency of the code, and there's 99 classes and 6K lines of code for the database. Yeah. So 3 packages is this, the soil file package is just to add file locking and things you need for a database on top of Pharo, because Pharo is still missing this. So, but this should emerge into Pharo someday, because this is useful for a lot of cases that you have system file locking and in-memory file locking. The serializer I will show is that the very beginning I thought there's a low-hanging fruit. We have fuel. We can just use it as a serializer, but it turned out that it is neither flexible and nor fast enough to do that stuff. So we wrote our own serializer. And of course, just the database. The main things, the buzzwords you need for a database is ACID transaction. That's just going from one sane state to another sane state in a way that even if the database system crashes, there is a sane state. So just so ACID is atomicity, consistency, isolation, and durability. Each of them has some artifacts, how you have to treat data, how you monitor, but in the end you need to go a long list of operations. Either everything is committed or nothing. That moves you from one state to another. MVCC is nowadays, so that's a good thing about Omnibase because it was from '98, and their MVCC was not state of the art. So that was quite good. But nowadays, Postgres, everyone has these. So Postgres was early, Oracle, they all followed up, and MVCC is just a pattern that every time you you modify data, you write a new version to the end of the file. So you don't delete the old version. So that enables people still read the old version while you're writing the new one. The pattern, the thing we say is readers don't block writers, writers don't block readers. Because that if you have, we said before, if you have pessimistic locking, there is no way of knowing. You just prevent people accessing the same data. If you commit or not, doesn't matter. Journal-based committing is one, especially the D and the C. That you have a twofold write the data. You first have one journal, which is a list of operations that should change the database. You write that to disk, you flush that, and then you start altering the database, because then you have a situation, no matter where something breaks or crashes, you can recover, because you had at least one version of the data. Demo time. So maybe it's better just to look a bit. I demonstrated on Monday, so maybe it's not very exciting for a lot of you, but so this is, can you read this, or should I make it a bit smaller or bigger? Smaller. It's okay? Huh? Small? Bigger or not? Bigger. Okay. Oops. Maybe more, once more. Good? Yeah. Okay, so I just take a simple example. So I refactor. So the first line is just to have a definition of what should be the database. And the database in soil is one directory. So you give it one directory. Huh? Can you make it bigger? My eyes are very old. Sure, mine too. It's okay? I don't know how to. Yeah, okay. All right, so the definition is database file system directory. So you give it a directory and the database can organize itself into the directory. Usually we would call just open on that, and then if you have a database, you just call open and then you have one. But now for demonstrating, we have a super destroy command, because just it nukes the whole database, and then initialize file system just makes the basic skeleton on the file system, so you can start with nothing but a database. Underneath it might be a little bit cryptic, but it's just to have a little graph to demonstrate something. So there's an attendee list, which holds a collection, which has person objects. So we can demonstrate at least the basic stuff that you have in the database. So when we execute this, we have the database, then we make the object. And to get this on disk, you have to execute these 3 lines. So it's transaction-based, so you make a new transaction. Then there is one root object. It's comparable to the special objects array in an image. So there needs to be one string at the top holding one object, and then you connect everything to that object to persist it. Same in Gemstone, same everywhere. And if we execute it, boing, now it's on disk, at least, if you trust me. So to see that it's on disk, we just make a new transaction, and then we like what we have in root, and then you see we have this attendee list with all the objects. That's basically all you need to persist your object, if it's small. If you have a big graph, like megabytes or gigabytes, so you will have thousands or millions of objects, and then you want to have the graph partitioned. So you just make the strings, and you write the address. So you're not attached, but here's a little node where you can find it. So that's the discoverability. And that we can achieve by, so this is the same code as before. So I made a look here for you. There's one line that changes right now. So because we have one graph, and before committing it, we tell every one of the person objects, so the one contained in the collection, you're B standalone object, yourself a root. And it will make the database writing the attendee list with just these references and write every person individually in the database as separate record. So if we execute that, and now if we make another transaction and inspect, then you can see here in the attendees now it's saying there's proxy object with some 1:2. The 1 is because we don't need it right now, but Soil has support for segments. So there will be all kinds of things. We're saying there is a segment of things where I put my objects in to organize either different directories, different files, or even network. We will see. It's a playground. It's an OO playground. So, but segments is useful to do that. And now, if we click on it, we just get the person objects because, as you know, all of them were proto objects. They did not understand what the inspector was wanting from them. And so in 5 times, it just resolved the proxy has the address and the transaction, and then it just goes over and gets to disk and fetches the object. So that means no matter how big your graph is, by inspecting through the graph, you just load what you're looking at, and the rest stays on disk. Same thing in Gemstone. Yeah? You have a huge stone, and then, there's a gem that just pulls in the one thing you want to work on, and the other petabytes just sleep.
Are they proxy objects, or are they become the real persons now in this example?
No, the proxy stays, because Become has trouble, and so there's no need for removing the proxy, so we just keep it like this. All right, so to the cooler stuff here is that what's really nice is that if we talk about MVCC, that means every change writes a new version of your object, and as long as you don't delete them, you have them all. And you can do time travel. So we just execute the same thing again, and here on the bottom I added dynamically 10 commits with more person added. So we have more transactions to look at. So now this will be a convenience method somehow later, but now it looks a bit complicated, but it's not. If we execute this, we get all version of this attendee list. So if we look at the last one, we see there's the 5 people we put in. If you take the next, there is person 1. And if you look at the last, there is person 10, all 10. So that means that in a transaction, every transaction materializes all the objects you're looking up. So if you have 3 transactions looking up the same object, you have 3 copies in memory, which assures that you don't stump on each other's feet. It's private to the transaction, and that's what you have for business logic. You don't want to have someone alter your object while you're working with it. So, and with this, that's just because we have the version and the versions are accessible. It's also an MSC property because every version knows its prior version. So we can just go to the address and then say, go down the previous pointer and give me all of them, and then I materialize them, and then they're like they have been yesterday. And even if you then go in the inspector and you go all along, it will materialize the old state. So you can't say, oh my God, now I want to traverse the graph how it was like yesterday. So then you make something like that reflects yesterday noon, and then take your root object, and then you go through, and then you get everything that was yesterday, if you need it or not. I like it very much. That's another, as some see probably in Markus' talk, that there is potential that we have. By the way, potential is that soil also has class versions. I was always talking about them. Gemstone has it, of course, and soil has it. So what we do when we serialize is that we call it behavior description, because I'm not the biggest fan of classes. So just behavior description is the name, the instance variables with its order, so it knows the shape of that version. And it always recognizes if the one object in memory or the one on the database is the actual version. So what happens if you put an old version and then you modify, you add an instance variable, the next time you read the object is saying, okay, I materialized with one instance variable, but now it's a different one, then it creates a new of this behavior description, then it auto-migrates all objects so that you have the object that reflects the code that you have in the image, because you have only one set of code. And the old object wouldn't fit. And if you have class versions, like in Gemstone, you would just, there's an array, the newest one is the newest one, and then you just go down and you have the class. So you could, like Gemstone does it, you can, a 10-year-old object is saying, so we have no need to migrate them, so as long as they're intact, so they just work as before. Okay, I'm not sure how much time, I didn't take the time. Okay, 10 minutes, good. One of the big assets, or one of the major reasons to have a database system, is that it provides binary search capabilities. So that means when you have a lot of objects, multi-million objects, and you find something, you cannot use something like an ordered collection. That's a linear scan. It would be horrible slow. So what you do is you make something that is sortable, a magnitude, a string, number, anything, and that you put in a large dictionary, and then you just go, is it the first, the last? If not, is it the middle one? If not, is it greater? And then you go half by half. So you have O log n search. And then, but there's multiple ways of doing it. So the usual way in these databases is B3+, which is a disk optimized way of having that. But I'm a different kind of guy. I not even have a degree. So I like the fancy ones, and I just got to know the skip list. Skip list is a layered linked list. You have like 20 layers of linked list, where you skip, in every layer you skip more nodes. So it gets more sparse to the top. So, and then searching, you start at the fast lane. You just bump over a lot of the nodes. And if you overstretch the goal with the key, you just descend one level, and then you go, which ends up being O log n as well. So B3 and a skip list are search-wise the same thing. And to use that, you have here, if you want to have something that has a lot of objects, then you make a skip list dictionary, and the max level is the number of linked list levels you want to have. And key size is to optimize the usage on disk. So these indexes are, the operating system always uses 4K. So the atomic read and write in an operating system is you cannot read or write less than 4K. So, and then you align your data. And then key size, I mean, why should you use a bigger key than you need? So we have date and time, for one thing in ActiveGrid, we have a chronological index with 10,000s of things, and then you just have a date and time. You make that a key that is sortable. it takes 7 bytes, and then you have a skip list with a key size of 7 bytes, and then you could go off and put any number of objects you want to have, even billions. So, well, it's to be proven, of course. Theoretically, I say, theoretically, you will have that. And it's used just like a dictionary. So Soil has multiple levels of dictionary. There's a system dictionary, the dictionary we have. Soil has a persistent dictionary. It's just it organizes all value as standalone objects. So on read, it just reads all the keys. So it's very fast. But if you need big stuff, you need to, and Markus is about to finish the B-tree version, because we have now skip list and B-tree, because sometimes the one is better, sometimes the other. And Soil is here to support use cases. So I didn't have time, but I had a prototype about the reason back then using MongoDB was because MongoDB was one of the databases that has geo-indexing, geographically, lat long, yeah? Because we needed it in the mobility sector. And I have a prototype that there is something called a geo-hash. It's called a Hilbert curve that is mapped onto a byte array or a hex string, which is workable, and that's also sortable. So you just need to that, and then you can make, if you have lat long in your object, you're just saying, okay, before storing that in my skip list dictionary, make that the geo-hash. The geo-hash is the key and the object, and then you have a geo database. Same thing goes for full text indexing, where you have trigrams indexed. So I have prototypes for most of that, but no time, you know. And that's one of the purposes that you, even indexing is individual. And you should make your own index, so I cannot know what indexes you will come up. So if there's 2 minutes more, then we'll just go to the last thing. So a bit of an outlook is the standalone serializer I could show, but in Soil you can, when you load Soil, you can, on every object you can just put Soil serialize. Then you get a byte array. On a byte array you can say Soil materialize, and then you get back the object. So we try to make that, because my plan is that at one point writing to disk is not the only one in the database. I want to send that over network socket, because you serialize, and then you have a way of communicating, like Postgres going first over network socket and files, and it's better than by people's judge, because you have to send it over network socket. Multi-index collections is what you also want. That means that you have, there's not only one way you want to index something. So let's say if a person name, you have first name, last name. So maybe you have an index on last name and one on first name. So you have multi-indexes per stuff. And that's one of the things I'm working right now, that you can say, okay, I have here an object, and this is the selector, the getter. So it will take for every object, it will take the getter and make an index for that. And then you can add any amount of indexes you want to have. And the obvious stuff at the beginning, the point is then you have a query planner. A query planner is something that looks at your query, and then it figures out which of the indexes it uses to be most performant. And what I said, the geo full text, you name it, index, that's the thing you can just hook on, because it's 6K code, 6K lines of code, and it's just the basis, and you can just subclass and make things out of it, and it might be useful. So I would now, questions at the end, I guess. Markus' part is now.
Yeah, so I want to explain a bit one reason why I'm interested in Soil and in this small database, and that is Soil and Pharo. So of course Soil is implemented in Pharo, but there are actually lots of interesting things in Pharo that look like problems that we could solve better. And so one that we still have is the sources and changes file. So if you ever, I mean, maybe you don't even know how it works. So source code in since Smalltalk 80 is actually not in memory, but on disk, because it's 40 megabyte, and you don't, in Pharo now, Pharo 12, and you don't want to have that in memory. So what is done is that you actually have for every compiled method a pointer into either .changes or .sources, depending if it's negative or positive, which is stored in 5 bytes in Pharo 12 now. And it's just the offset into a file. The reason why this mechanism was done is that we have multiple needs for source code. So one is, as I said, it's 40 megabyte. The image size is 53 megabytes, so that means it would nearly double the memory, and in old times it was even worse. It was the image, because of 64-bit, before 64-bit, the image was even smaller compared to the source code. And people don't want that in memory. Partly because it blows up the image, a garbage collector, and so on and so on, and it's hard to make it optional and things. But of course, with the perm space work in Pharo, this might change, that we could just have it in a perm space. But it's not the only need that is solved by the .sources.changes. The other one is history. You might know that we have two kinds of history. So one is when you accept the method, it is stored in the .changes file, independently of which source control system you use. So Git only stores a version after an explicit commit, while Pharo stores another for every accept, which is actually nice. It means that you have a very fine-grained commit history of your session without having to commit constantly into a revision control system. And I actually want to keep that. At some point I thought, oh, we don't need that, we can get rid of it. But it's actually quite nice. Another thing that it actually solves is the need, or that it solves is the transaction log. So one reason why we have a .changes file and commit every single change is not, I think the history is more accidental. What they wanted was the transaction log. So every time you accept code, it's on disk, so that if your image crashes, you don't lose all your source code that you have not yet committed differently. And in old Smalltalk, there was no other commit, so that means if you don't save your image, you lose your code. Or if your image you save, but it's broken, you lose your code. So transaction log. In the changes, you have all the code, all the class definitions, all the comment definitions, and you can reload them when in the same image if it still loads, or in another image, because it's just a text file. Very, very nice. So we don't want to lose that. But of course, there are lots of problems too. So right now, if you open a Pharo twice, they both write to the same changes file. This is not good. Not as bad as you would think, but not good. Another thing is internally to Pharo, it's actually not thread safe. So if you have two processes compiling code and trying to store stuff in the .changes, this will not be nice either. And then it uses very simple caching. I mean, it's a big text file, and going to the text file, you don't want to do it all the time. So it actually uses a quite simple caching scheme, which I think just loads this whole thing into memory. So this idea, oh, it should not be in memory, is kind of not really true. And the additional thing is that the format is very, very simplistic. So this pointer points to the code of the method, and then there is a preamble, which you can only pass by going back to the prior exclamation mark, and then you need to pass the text. So this is really slow. Yeah, not good. So if you then look at Soil, it actually has all these things, but much faster. So you have a transaction log. So every time you commit, it is written out in a transaction log. So you don't need that feature anymore from the .changes. It supports accessing old versions because it is MVCC, so it's append only. And if we would update the string that is in the database, we could just ask for all prior versions and we would get them. And as we control what we clean up in the database, we could actually, in that use case, just keep it and flush it, for example, on git commit, like now. No, we don't even flush. You could flush it at some point if you wanted to. How would you do it? You would just store a Soil object pointer, just as we store now the offset in the compiled method, and it would work naturally. The Soil object pointer is, of course, a bit bigger than the 5 bytes, but who cares? Yeah, and in addition, it would actually solve the problem of multiple image opening stuff, which I think right now is not yet supported in Soil, but in the future it will be, that you can open a database from multiple images easily. And it's, of course, inside of the image, it's thread safe, and so it would actually solve all these problems. And it should actually be much faster. In Pharo, we have another change model, so another log model, which is a higher level. This one actually, Epicea logs events that you do on the level of the domain, like method added, refactoring done with these intermediate steps. Very nice to have this high-level model because much easier to analyze. But it is stored in text files, and that's not really fast either. So it might be interesting to instead store that in the database, and then to ask the question, do we need both logs? We need to see. But the EPCR is on another level. It's not on the level of we change a string, but it's on the level of what you change in your model. Interestingly, when the serializer was finished, this was the first thing we tried, that Norbert tried. He said, you think the serializer works? No, let's check. I will store the EPCR model on disk, and it worked immediately out of the box. That was really nice. Yeah, then the next thing that might be interesting is indexing. So you might know or not that we have no indexing in the system. So that means if you ask for senders off or implementers off or do full text search, this is actually done all without an index, but it just goes from method to method and checks if for example, the selector is in the literal array for senders off. This, of course, cannot be fast. There are projects that add indexing to the system, multiple ones, but it might be interesting to actually do that by default and do it in a way that the index is not in the image. And Soil has this idea that indexes actually are stored in 4 kilobyte pages on disk, and you do actually not need to load the whole index back into memory to do a query. So that means you can actually have a full text index on disk and do a query without spending lots and lots of memory. So that is something else to explore. Another thing that is interesting is how do we store resources in the system? So what people sometimes do is they have base 64 encoded strings in methods, which is not a good idea, because if you think about it, then you will have this string in the image. It's not only in the source code, it's in the image too, because it's a literal. So that means then you have this big string in the image. So we sometimes check for big strings and then try to get rid of them, because this is not a good idea like that. Even so it feels like that resources, it's not. It takes memory. So another trick that people came up with is really nice, is to actually use the method command. So they store actually a string for tests, like EPCR has lots of tests like that, or even a base 64 encoded string as the first method command. And then you, in the method itself, you write the code that actually reads that comment. And this way you actually store the string only in the dot sources or dot changes, and not in memory. And that means you upuse the dot sources and dot changes as an object store, because the base 64 encoded thing is of course an encoded object graph. Success, yeah. So I think we should do better. So one thing is, this one is already horrible to use, so we need to have some integration with Git so that resources actually end up in Git in a way that it's not source code. I mean, you don't want to map everything to classes and methods. It's a bit this funny thing that we always say, we know how to model object-orientedly, but as soon as it's about code, we say, there are only classes and methods. Whatever you do, it needs to be a class and a method. There's nothing else. If you want metadata, it's a method. If you want to have describe a package, it's a class. That's really strange. Why can we not use the power of objects to describe our system? And the reason is that we have no way of storing them nicely. So we should actually experiment with that. And then the next step is, why can we not do even more? Why don't we store the whole history of the system in a database? If you have the database anyway, disk space is cheap. If you download any shitty stuff now, it's like 600 megabytes, and why do we care? Yeah, on disk, we can just do it. So why not have the whole history of the source code in the database with queries that you can get old versions? Then, for example, if you have this nice deprecation transformating methods, but at some point you need to get rid of them because they poison the API completely and you have too many deprecated methods. So we now remove them at some point, but then they lose their value because then people don't know that it's just a rename, the DNU. So what we could do is we could, on DNU, we could ask the database, do you know if maybe in the past there was a deprecated method with a rename for this DNU? And then the database says, yeah, so here, the transformation, you can do it. And then it could actually do the transformation. Just one idea. Another question is, why not do that at the AST granularity? Why store text? I mean, we always say, Smalltalk is not text, it's object. Why don't we just store the AST of the whole history of the system in the database, and then allow people to annotate any AST node with information as they like? Why not? that's it. And sadly, I had no time to do anything. Yeah. Questions for both Norbert and me? Questions? Yeah.
I have one question slash recommendation. Maybe it's mostly for Norbert. As you're aware, one big challenge with serializers is when the serializer, for whatever reason, could be something in the serializer or because of external reasons, you need to change the format of the serializer. So I think that your serializer needs to be very, it should support updating from previous.
Questions? Yeah.
I have one question slash recommendation. Maybe it's mostly for Norbert. As you're aware, one big challenge with serializers is when the serializer, for whatever reason, could be something in the serializer or because of external reasons, you need to change the format of the serializer. So I think that your serializer needs to be very, it should support updating from previous format versions, because otherwise
Yeah,
you won't be able to
Yeah,
read your code anymore.
We have that.
Yeah, so what we have already is, so these behavior descriptions are flattened views of the class with all instance variables flattened by name with where the position is, the position where it's stored on disk. But then when you actually read back, you read the position on disk, but then to store in the current instantiate the object, and then we write by name. So we do not use offsets, but we say, person, the person object had last name, so we read offset 2 from disk, and then we say write last name. And if the user in the meantime changed from first name and last name and changed the order because he had it wrong, we don't care because we write by name only. And this means too that if you move in between the hierarchy, you move an instance variable up, we don't care. We can still deserialize. We have some support for class renames and plans for instance variable renames. But another problem is, of course, changes of Pharo classes that are then stored in the database, and there we need to build some more infrastructure to make that easy for people to actually. But that's, of course, our duty then as the maintainer. So Pharo classes that change structure, like UUID, change structure in Pharo 12, it's our duty to make sure that we can read the old UUID format and instantiate it.
What did you mean, the format of the serialization?
That's I understood, Marcus. That's one part of the problem, which makes total sense. The one I was thinking about is the internal format of the serializer.
Yeah.
Not sure if I am clear. Not
sure. We need to talk
like
about.
For example, in Fuel, we have changes in the low-level format.
You mean that you can read older Fuel with newer code?
Yeah, for example.
We don't have that yet, but I mean, it's an unnecessary huge amount of abstraction levels in between. So we wait for the problem. So from the database perspective, the header of the whole database has some database format version and stuff. So you have all the hooks to say, okay, in case we change, we have a hook saying,
exactly.
This database is way older, and if it comes to database, a manual migration stuff. So, but we are, for instance, Soil has also a one field for application version, because if you store your model and you want to change it, you want to have support from the database, because in ActiveQuid we have an auto migration scheme that exactly detects that. If you're saying, okay, the image has newer code than the thing in, and then whenever the user logs in, it's saying, so, oh, your version is one lower than it should be, and then the migrator kicks in, and usually you don't notice because it's not milliseconds, but 10 milliseconds to migrate. So all sorts of this, but yeah. And these ideas should all go in, yeah.
Thank you very much.
collections. But aren't they already there? Because you can just make root through all the objects, and they store two of your binary search or collections which reference the objects. If you have object identity, then it will be also.
Sure. You can always hack around. So,
Okay,
but
this would be the current solution, and you want to have to make it in one collection.
I mean, the current state in a database is there is one primary collection that's holding on to the object, and then there's secondary indexes making another binary search on the same data. So, and you don't want to manage yourself, and the point about multi-indexing is you get one add put, and then it's added automatically to all the indexes. That's the index maintenance should go automatic.
One application case that came to my mind is if the file does not reside in the same network as the client who is using the database. So between the serializer and the file access could be a Pharo network connection. Do you plan to do that without talking about the risk of concurrency problems, that some multiple access to that Pharo file that should not happen, but anyway to have a cut between the point where the serializer works in the client and the file access that could be working remotely. So how would we deal with that?
Well, the easiest way to deal with it, we don't do it.
Okay.
So for the time being, I mean, the whole point about soil is that people always forget is that you have a memory layout of binary that goes directly to disk, and all of the small, so that I could show you about iterating. An iterator on disk, you can use Smalltalk to iterate, and you will lose all of that if you use it over network socket, because then you have yet another format you map to. So that's exactly the point in soil. So maybe later. So people also always ask about other languages and saying, yeah, but then you lose the whole point. There's other database systems that might fit better
I
for that.
expected it to be complicated or nasty, but I was just asking if
I mean,
you had it in mind.
Just for you, I looked at Raft, how hard it is to implement, because it will come in one way. Yeah, so Byzantine stuff. So, but yeah, we just started. It's the jump button.
Can you say a word on the closure serialization?
Yes. So it's in the current version, it does not do it yet. I mean, there is code, but I'm not sure if it's committed right now. So closure serialization would have been another interesting talk, because with full blocks, there is.
You can say that you have clean block serialization. That's okay.
We have clean block serialization.
So you have
So for
Full blocks is the only
for real blocks, one thing is at some point you need to have the code in the database too, because the blocks are code. So without storing code versions, storing blocks always is tricky. And another thing is that right now, if you serialize a block, it doesn't know its outer block. It searches itself by identity in the outer block, and you cannot find yourself again. So we need to actually fix Pharo itself. We need to actually fix the closure model. Fuel has the same problem.
That's the point of soil. You have to fix Pharo to use it.
Yeah, exactly. No, the message is that you save clean blocks.
Yes.
Okay.
Yeah.
Since 6 months,
No, but
9 months. Yeah.
No, I think the clean
Yeah.
blocks we can store already. Yeah.
It's so long ago we forgot.
Yeah.
Because you see for the sorted collection, blah, 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 blah.
Yeah,
That's easy.
You can do this.
You just want to have clean blocks.
there's
So
even
for-
tests.
There's even a test for
Yes,
sorted
tests
collection.
for
Yeah.
collection.
Okay.
You will be happy.
Because for full blocks, it's a disaster.
Sorry, I have another question. So if we deploy, I'm thinking about deployment for Pharo, if you do this, would that mean that instead of the user just needing to download the dot sources or dot changes, whatever, now they will need to download a whole directory of soil database, right?
That would be the
Yes.
thing, yeah. But then if you look at the new image format with the perm space, it is multiple files already. So, and .change also are multiple files too. So.
And on Mac, we could tell you that this is a file, but in fact this is a directory and you will not know it.
Exactly, yeah.
And then we have to check for endianness. Of course.
Okay.
Any more?
Good. I need to give a second talk, and I have only 10 minutes. That will be difficult.
So when do you plan an official release?
This ESUG not, but in a couple of weeks. It's just
Okay. No,
there's a few hacks I want to remove, or we want to remove.
Okay.
So within this year.
It's a literal. It feels like it should cost nothing, no? I mean, and yeah. But if you change it to this and you do a benchmark, you will get, so now, the only thing I did is I removed the block around the 2. And as it's just a literal, and we implement value and object in Pharo, it will send value to the 2. Value is return self, and so it's exactly the same like block, the constant block. And if you then do a very trivial benchmark, like the benchmark you do to just find out what is going on here. So we take, we make morph new and make sure that it's outside of the benchmark, and then we call min height in bench, which just executes 5 seconds, how often, which means very often. And then you find out that this method is now 3 times faster after I remove the block. 3 times. Which is, of course, just a micro optimization, but it's a lot. And if you then look at it again a bit without the overhead of the message sent, then you see that the execution, so sending the value, is around 40% faster to send it to this return self instead of executing the block. And if you combine the 2 together and you do absolutely nothing else, then yeah, block with 0 value, and then you do bench, and in comparison without the block, you see that it's around 6 times faster, this code, which is interesting. Of course, it's a micro benchmark, and in the big picture, I don't know, but it's interesting. So the question, what's going on? So of course, this means we need to look at the bytecode to see what is happening. And the case when there's the block, then what is actually happening in Pharo right now is that it actually creates a full block closure with the bytecode that is used for that, for this. And that means that the compiler, from the compiler side, it actually compiles the content of the block as a compiled block, which is a bit similar like a compiled method. Both are subclasses of compiled code. And it adds that compiled block to the literal frame, and the bytecode accesses the literal frame for this method. That's why full closure white has the block in the printout, in the pretty printout, and it then pushes the closure. The VM creates the closure and pushes it on the stack. For execution, so the value later that you send to the block, it's actually a primitive method. So that's already nice. But if you think about what the primitive does, it's already a method execution. So you have a lookup, then a primitive, which is fast. But then the primitive leads to executing the compiled block of the block. So that means sending value to a closure is kind of like 2 method executions. It's the value method, primitive, very fast, but the lookup has to be done, and the execution that it actually tells the VM, you know, there's a compiled block here, please execute it, which might even then, the JIT compiler might even create at some point code for it and all these things. If we compare that to the constant, then the creation, of course, constants exist always, so you don't need to create them, so they're literals. The only thing that we do is we have it in a literal frame when we push the value from the literal frame. And then we continue. So that's, of course, much faster because we don't need to create a block. It's an existing object that gets pushed on the stack. Much faster. And value in object is just return self, which is a quick method, so kind of a bit like a primitive and fast to do that. So now we know why it's slow. So block creation is slow because it creates objects. Literals are faster because you don't need to create an object. The value is slow because it executes two methods. The value method that you send and then the block itself. So now the question is, do we actually have examples of that in the image? Because if we wouldn't, this is all, of course, useless. So here, I actually need some Pharo running. Let's see, Pharo. I should have prepared that. Oops. No. So now we have Pharo. Now we go to settings, make it bigger. Maybe like that. And now we can play with these things. So what I want to do is I want to get all blocks that we have in the system from the level of the AST. So that means I say Smalltalk global methods, which gives me all methods, then flat collect method AST block nodes. So this will take a while because it needs to create the AST of all methods. So we will see how long it takes. So it should be like, hopefully a minute or something like that. So this is the problem if you need the AST of the whole system. And then we have all blocks. And all blocks means even the blocks that are actually no blocks, like an if true, to do in Pharo 12 now, times repeat, the block is not a block, things like that. But then, if we have all blocks, we can, of course, then filter out the blocks that we're not interested in. So you already see in the next line that we want to filter out all the inline blocks. So exactly the if true, if false that we are not interested in because they are actually not blocks. And then, in the last one, we actually then go to the, this is too slow. I wanted to prepare it and then I forgot. So yeah, and then we can actually lower it down, and from the real blocks we can then actually ask is constant to the block, which is actually a method that I implemented to discover if a block is just returning a constant. This is slower than it used to be. I need to check that. Yeah, it used to be that we cached just all ASTs. So that means that your image could grow quite large. And then now we have in Pharo 12 a change where we cache only a certain number of ASTs, which is for normal use case exactly what you want. So if you browse around, but it might be that in this case it actually invalidates the cache too often. So I need to actually check that. Yeah, but I wanted to show them in the inspector, so show a bit the nice inspectors that we have. But yeah, let's skip it. Let's continue. No, I didn't know that it was so slow. That's a bug. So, but we can see how it looks like. So we can then inspect the block node, and you see it looks like that, and it has a nice mapping to where it actually used. Quite kind of nice. So, show the number. Yes. So we have blocks in Pharo. It's interestingly less than methods. So it's around 86,000, 85,000 blocks in the whole system, including optimized blocks. If you then look only at non-optimized blocks, it's down to 36,000, 37,000 blocks. And the ones that are constant are actually around 2,500 constant blocks, which is more than I expected, especially as we already refactored a little bit the code to use constants in morphic accessing methods and things. So it's interesting. We have 2,500 cases like this. So what do we do? As I said, we started to rewrite the code because you can just remove the block and everyone is happy. But it looks a bit ugly. It's hard to explain. Why no block here, but an if to a block? That's not good. Then what about blocks with more than 0 arguments? I mean, in object, we don't have value with 1 argument and value, value, and value, 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 and value with arguments. No. So that doesn't work. Then another idea was, we have a compiler. We can just take the compiler, detect this case, and in case it's a constant block, we just compile the literal instead of the block. They are the same problem, what with more than 1 arguments. And then it's not nice for the mapping between source AST and bytecode, because then you have on the level of the AST, you have a block, but on the level of the bytecode, you don't have a block, and that could lead to very strange effects. And it's yet another place where the bytecode is out of sync with the AST, and we found out that this is something we want to reduce. We want to be closer to the AST with the code that we give the VM, and we want to do all the optimizations in the VM later on that level, not on this. So then we had, the idea was, why not just compile a wrapper? I mean, you could just put the constant into your own object with 1 instance variable, and then implement the API of block closure. So value is return constant, and as return constant, return this instance variable constant, and return self is around the same speed. Yeah, it's just a quick method, so that should not be that of a problem. So we could actually just do that. We could create a class with 1 instance variable, the API of a block closure, and then the compiler could store this new object directly in the literal frame and just push it with push literal, with push constant like the constant, and it would actually solve the problem. And that is actually what we did. But there are even more problems. So then the problem is send us off. So as you might know, if you say send us off to look who sends a message, it even looks at symbols. So if you have send us off a symbol and you have a block that only contains a symbol, it should actually show up this method in send us off. So that means that send us off iterates into embedded blocks into the literals there. And so that needs to be taken care of. So, and then implementing all the API of block closure again on this feels too much. But then the idea came that we could just compile a compiled block and keep it in addition. So that means that this wrapper now has the constant and the compiled block. And then we can just, like in a closure, just delegate everything to the compiled block that talks about compiled block. And if we do that, we can just make compiled block a subclass of block closure and inherit all the code. And that is what we actually did. So I can show it in the image. We are now done. Yeah, 86,000 blocks. So but I wanted to know, because we have no time anyway, I wanted to show you the block closure hierarchy. Let's go to block. I always do this wrong. Closure. Let's go to block closure. So what we did is we made constant block closure a subclass of block closure and a subclass of clean block closure, which I will not talk about at all, because it's a certain special kind of clean block. So I will have a tiny slide at the end about that. So now it's actually a subclass of clean block closure, the constant block closure. And yeah, exactly, clean block closure, here it is. And it has, historically, the literal is in the superclass. It has some reasons I need to, I actually forgot why. So it should be here, but it could not. So we have an instance variable literal. And then we implement an accessor, and we implement all the value methods. And we need to actually implement all the value methods because they are different for the different arguments. And that's why in the end we added even subclasses, because you need to raise errors correctly. Oh, sorry. Ooh, I'm a bit handicapped. So you see that here, for example, it returns literal for if it's one if you send value, but if you send value with an argument, it actually says numark error. And you need to do that for all the different number of arguments. So that's why we have subclasses for all the different. So there are only 4 argument messages as you use value with arguments. For now, we support 3 arguments because there are no 4 argument closures in this clean closures in the system. But that could be easily extended in the later. So error handling, that's why we have the hierarchy. So the compiler, in the end, what it does is it's checked in the method that compiles closures. It checks if it's clean and if it's constant. And if it's constant, it calls this method, which just creates the constant block closure. As you can see, as you can see, and then it creates a compile block that we will never execute, but that we need for senders off. And then it just pushes, it just creates a push literal instruction, which makes sure that then this is on the literal frame and it's pushed there when executed. And this is how it's implemented. And the nice thing with that is that all the mapping of things work. So we can now browse all sub-instances of clean block closure. Let's see how Steph, this selecting is sometimes not good with the hash. Browse, playground. Because now I need to remove the hash here. So all sub-instances, and now we can inspect it. And we see all our 2,500 compiled constant blocks. Is it actually? Ah, yes. So interestingly, yes, you're allowed to access this context in the constant block too. So for example, we have here test clean block closure has actually a test of that. And the nice thing is that the mapping works as you would expect. So that means even though we look at the closure, it knows how to highlight the text in the method where it is defined. And that even so it does not have an outer context, and which is actually kind of nice that it actually works. And you can see all the use cases where this happens. So for example, empty block is of course a clean block too. Scrolling is shit. Yeah, you get the idea. Yeah, and then I wanted to show something that is kind of fun. That now that actually, as we said, we have a value method implemented on clean block closure, this method will really be executed at runtime to evaluate blocks. So that means we can go back to our browser. We go to constant block closure, go to value, go here, get the menu. How do we get the menu? Like this, debugging, add counter. So now we have a counter installed on value, and if you look at it again, it's already at 75,000 invocations. If we just go away, go get, we had 83,000. So it's actually now already called quite a lot in the running system. Because of one of the methods, the min height is actually a method that is actually actively called in Morphic, and that, as you see, if you move a morph window around it, it goes like 166,000. So that is what I wanted to show. I did not talk about clean blocks, which is another talk. So the idea is that this notion of being able to pre-compile a block and not having to create it at runtime, there are other blocks that you can do that for, but it's more complex because the debugger needs to deal with them, while constant blocks you never end up in the debugger because they don't call other methods. Yeah, so that is it. questions?
Have you tried some macro benchmark, like compiling all the...
So I tried to do a benchmark on the compiler itself to recompile the image, but I couldn't get any improvement. Partly because I think that reading from disk, the source code is most, or yeah, it didn't show anything. That's a bit missing. So I actually need to find some benchmarks that show any results in for bigger systems. One thing that why I thought it was good to do is that it's called a lot in interactive use. So the morphic property handling uses it a lot. And so I think that anything that is called when moving the mouse or moving a window around is worth optimizing. But yeah, that's one of the weak points is that it was not driven by macro benchmarking. It was driven by this micro benchmark. Like, what? This method is 3 times slower. Let's optimize that.
Marcus, if I remember correctly, the original method, the block with the constant was 3 times slower than just the literal, right?
Yeah.
So the question is, did you have the time to benchmark with your new solution to see how far you were able to get closer to the literal?
So the constant block is the same speed than the literal, yeah.
Okay,
Because
great.
it's return.
As far as you can go.
It's return instance variable compared to return self, so it's maybe a tiny little bit slower, but not much. I mean, nearly undetectable.